Hello, this is Nas from NB Network Lessons. Hope you guys are doing okay. Today, my topic is calculus. This is my first lesson on calculus, and I welcome all of you. So, without any further ado, let's go ahead and get started. If I have to define, first thing in calculus is what we're going to discuss is derivative, right here. Okay. If I have to define what a derivative is in one word, the way I would do it, I would say slope. Slope of a line, slope of a curve, slope of a function. So derivative is nothing but a slope. What it means is that rate of change. How? Let's see. So you've got this axis right here representing distance, and this axis right here represents time. So let's say in 1 second, you cover 1 meter. In 2 seconds, you cover 2 meters, okay? So basically, this distance right here is changing. This distance is changing with respect to time, okay? That is what derivative is. Rate of change with respect to time. So in this case, what I can say is that if I want to find a slope of this curve, what I do is that I pick a point on this curve. Let's say I pick this point right here, and then I draw a tangent line like this, which barely just touches this point. Okay, now we have obviously x coordinates over here, we have y coordinates over here. Okay, if you recall from my previous algebra lecture, what is slope? Slope is m is equal to y over x, or essentially it's like y2 minus y1 over x2 minus x1. All right, so essentially this slope right here is going to be different at different positions on this curve. So that's rate of change of distance from time's perspective. Now to my physics lover. If we have velocity, if we go on, let's say if we go on, I don't know, maybe, let's say this velocity is basically increasing, right? I'll draw a graph like this, okay? So this is velocity. In 1 second, you're going 1 meter per second. 2 seconds, you're going 2 meters, okay? And so forth, all right? So now if I want to find change of velocity, change of speed with respect to time, what would I do? Find the slope at a given point. Let's say I find a slope at right here, okay? So then my slope right here at this point, obviously I'm gonna have like x coordinate, I'm gonna have a y coordinate, okay? And then what I do is I find the slope m, and that would be my friend's derivative, okay? All right, jumping on to acceleration. Acceleration, you put your foot on your gas pedal in your car, you know, if you put your foot and it's at a constant value, you're not really increasing, your rate of change is not increasing, your car is going just like this at the same acceleration, okay? How would you plot that with respect of time? Your acceleration is not changing. So in that case, you will just have a straight line, okay? And what would be the derivative of the slope line? 0, because it's a constant. Nothing is changing. Over here, distance is changing with respect to time. Velocity is changing with respect to time. But over here, acceleration is not changing with respect of time. It's straight line. So in this case, my m would be 0, okay? So now, one thing before I close the session, I just want to say that these are given facts, that derivative of time is velocity, okay? And derivative of velocity is acceleration. These things are given in physics and calculus. So you have to memorize that, okay? I hope you enjoyed it. I'm gonna come back and we're gonna have some more fun in calculus. So watch this video maybe 2 or 3 times. It will make sense to you. If you have any questions or doubt, text me and let me know. I'll try my best to answer. Thank you so much for watching. If you like the contents, go ahead and give me a like. Thank you.